Welcome back to First Take Math. My name is Brian Thomas. Tonight's lesson we're going to work on the distributive property. Another way to think of the distributive property is I like to use the phrase rectangular thinking. Now again, a lot of this thinking for me is fairly new. I grew up in a very traditional way of teaching algebra, and so I'm just learning these ways just a few years ago. Khan Academy was a very good resource, and also a lady by the name of Jo Bowler. She's been very helpful. She's an instructor at Stanford University. I followed a few classes on her online that really helped me out with some thinking. She's got a special website called U Cubed. If you're interested in just playing in math, if you're one of those math geeks, that's a very cool place to play. So what I want to do is do 4 examples modeling the distributive property. So when I look at this problem, 5 times 32, what I should see is there's a 5, but instead of saying 32, I can break it up into pieces. I should see that as a 30 and a 2. Okay? So when a problem looks like this, we were taught to just go, well, 30 plus 2 is 32, and then you're back to 5 times 32. We're following the order of operations. But that's not the only way to do this problem. I can leave it as a 30 and a 2, and I can bring it over here into my rectangle. I have a 5, and then this edge would be a 30 and a 2. So I don't necessarily have to put that 32 back to this. I can leave it in that format, and now all I've got to do is find these 2 pieces. And we know that their rectangle, just multiply these 2 sides together. 5 times 30, again, 5 times 3 is 15, add 0, so 150. 5 times 2 would be then our 10. Our grand total would be 160. So we can see that rather easily in that form. So essentially what we're picking up on is we're kind of distributing the 5 through the parentheses. That's why it's called the distributive property. So it's got a blend of multiplication and addition. The outside is multiplication. What's on the inside is actually addition. And that's how you're going to see problems that can be modeled using the distributive property. So look at this problem. I got 3 times x plus 5. When I see something like this, this tells me that I can use rectangular thinking. The outside edge is going to be a 3, and then this runs across the top edge for me, an x and a 5. And then I can decompose it into 2 rectangles. Again, I have to multiply. Well, 3 times x really is just written like that. 3 times x, there's nothing else to do with that. We can't do anything until we know what x actually is. And x has not been defined at this point. And 3 times 5 is then 15. And we learned, like we did this problem, we add what's inside here, 150 plus 10, which would be 160. But on this problem, 3x plus 15, I really can't add those together. Because remember, 3x is really a bunch of x's, and a 15 is actually a bunch of 1s or a bunch of 5s or something. And I don't want to write all that out, but we kind of see that this is like apples and oranges. So 3x plus 15 is as far as we can go with that. So our answer to this problem is just 3x plus 15. And we refer to that as being simplified. We really can't do any more calculations than that. So right now, that's kind of meaningless to us. 3x plus 15, what do you want to do with that? We haven't got that far yet. So for me, a lot of times, this is like the ABCs. Why do you teach the ABCs? It's a learning process. Without the letters of the alphabet, you can't read or write. So if you're trying to do algebra, you have to understand some of the algebraic language. And this is going to lead me to applications down the road. So if we look on to the next example, we have negative 3 times the quantity 5x minus 10. Again, I'm allowed to look at this as a rectangular thinking, where the negative 3 goes along this edge, and the 2 pieces here go on the other side. So the 5x is one term, and the negative 10 is the other term. So I look at this as 2 pieces, a 5x and a negative 10. And I break this apart into 2 rectangles. Again, we have negative 3 times 5 times x. Well, I can multiply negative 3 times 5. We know 3 times 5 is 15, and one negative just means it stays negative. So this just becomes negative 15 times x, or we write that as negative 15x. And negative 3 times a negative 10, well, we know that's just 3 times 10 is 30. And we know that a negative and a negative flip that back to a positive. So our result then becomes then this negative 15x and a 30, or negative 15x plus 30. So for this example, I get negative 15x plus 30, and again, that's what we refer to as being simplified. That's as far as it can go. These are not like terms. You also can note there that what's happening here, and this is what's called the distributive property, is we're distributing the negative 3 through the parentheses. And when you do that, notice that there's no longer any parentheses. What we come out with is 2 terms without the parentheses. My next example I have is a negative 7 times negative x plus 2. So we have a negative 7 goes on this edge, the negative x and the 2 go along that edge. And again, we decompose it into 2 rectangles. Well, we know 7 times x is 7x. And a negative times a negative is still going to be a positive. So a negative and negative, that just flips it from a negative back to a positive. Negative 7 times 2, well, that's just going to be a negative 14. And so what I see is our 2 terms, 7x and a negative 14. And that's our shortcut way of writing it. We don't have to say 7x plus negative 14. We can look at this as simply 7x minus 14, or 7x and a negative 14. Okay? So when I do this problem over here, we would say our answer is 7x minus 14. And again, that's as far as that goes. And we use the phrase simplified. It can't go any further. That's as simple as it gets. And again, you should be able to see the distributive property here. The negative 7 and the negative x, and the negative 7 and the positive 2 is coming through there. So we're seeing that happen. And that's why we call that the distributive property. So again, thank you for the lesson, and we'll see you tomorrow.